Awesome. All right, can everybody hear me? Is this working in the back? Yes. Awesome, great. Thank you everyone for coming out. So some brief intros for myself and Justin. My name is Peteroy. I'm a founder of a network security company. Before that, worked on product security at Microsoft, some of the bug bounty programs, as well as Windows and Internet Explorer. Before that, I worked as a technical director and subject matter expert at the U.S. Department of Defense. And otherwise, I've given a lot of conference talks. And yeah, I think that's enough about me.
Hey everybody, my name is Justin Warner, security engineer working with Will at Iceberg. Previously did some time in the military doing really fun cyber things, and then transferred over into consulting where I spent 3 years with a team called the Adaptive Threat Division, worked on a lot of open source projects, did a lot of red team stuff. Got tired of sending the same phishing message over and over for years at a time and getting into the same organizations, and so I decided to transfer into Blue Team to solve some challenging problems, figure out better ways to do this.
So essentially the whole reason why we're here, one of the things that we do at Iceberg is we work with a number of different customers. We help them manage network monitoring, and one of the big things that we've seen, and I mean EFF has a booth out there where they also will talk about like things like Let's Encrypt, but you know, realistically we are seeing more and more traffic on the wire be encrypted. And so this has some pretty interesting impacts, which we'll talk about throughout the talk. But realistically right now where we see things, we're seeing like essentially between 35 and 45% of traffic be encrypted. And so that's actually like, just for the folks that are like, oh, I wonder if he means north-south or east-west traffic, it's primarily north-south traffic. So east-west workloads, like that's a whole nother talk that isn't this talk. So effectively, not really sure where everybody's at with network security monitoring and how everybody kind of understands it. So just gonna like do a couple high-level slides. So those folks that are like, yeah, I know this, please bear with me. For folks that are, you know, are at least interested in this and want to set the background, just we'll move through it pretty quickly here. So effectively, if you look at all of network security monitoring as a, you know, kind of as a capability, you essentially have effectively a quadrant system that exists here. So we have essentially batch and real time, which is talking about like, are we processing data, like are we collecting data at rest and processing data at rest? Real time is something more like an IDS system where we're processing data in stream or in real time, either like on the network itself, or like we can have real time analytic systems and like data pipelines behind that. We have content, which, you know, in network land means PCAP basically. There's a number of other proprietary formats, but PCAP is kind of the one that we've all decided to agree on, is how we talk about network security and full content binary data. And then up at the top, we have metadata and content there. This can mean basically anything that you can output into a structured log format that isn't binary data. So effectively, when we get into encryption's impact on the quadrant, effectively everything that is content-based just disappears. So effectively what that means is we no longer have content inspection. So like all of our, you know, our layer 7 firewalls, our fancy, you know, sandboxes that we've bought that sit on the network and extract artifacts and files, like all these capabilities essentially have gone away. We also don't have any signature-based capabilities, which for those of you that have been doing network security as long as we have, like that's where a lot of this all started, was like, I mean, Snort. Raise your hand if you've used Snort or seen Snort, and yeah, okay. Yep. And I'm now also basing where I am on this talk and where the audience is. But yeah, I mean, like Snort basically, like encrypted traffic, essentially like you are evaluating byte patterns, and those patterns don't exist because that's the whole reason encryption exists. And so realistically, we get pushed up to capabilities that are either batch or real time on top of metadata, because that's really all that we have left. So I guess like the other piece of this is setting background on like, do attackers actually use encryption? Is this a real thing, or did these guys just submit this talk so that they could like sound cool and get a talk submitted and like accepted to BSides? This is actually a real thing. There's lots of different actors that use encrypted command and control. Everyone from your friendly neighborhood pen test or red team, all the way up through a lot of the criminal actors. Effectively, you know, we took our nice pieces here. It actually ranges from like self-signed certificates, which you'd be like, oh, there's no way an attacker could do that and that would work in a real network. It totally will. All the way up to folks that are like establishing like legitimate EV infrastructure and doing that. But the majority, and where we'll talk a little bit later, is around domain validated. So essentially DV certs. are pretty much the easiest area for kind of abuse, and also like if you're here from the red team side, it's the easiest place to get encryption and bypass all of the controls that we just talked about. If you're here from the blue team side, it's the area where you're going to have attackers doing that the most often. So this could mean, so I mean, it's really funny because sometimes like there's this like age-old like grudge match between network and host-based security. And so some of the host-based security guys are like, all right, we're just going to give up on network security. Encryption's just making us terrible. If I had $1 for every time I talk to anyone, like whether it was like as a vendor or like as a consultant before that, or just talking to folks like, oh, well, do you guys terminate encryption? Like this is like, if we don't terminate encryption, like everything's just going to be a pumpkin. Like, I mean, the majority of traffic is still unencrypted, but like we're not going to just surrender and like let this be over, because otherwise we wouldn't have a talk. We would just be like, we'd be done, we'd get off the stage, and it'd be over. So effectively, what happens is we do end up with two options. So one is we can say like, all right, encryption is a thing, it exists. We're now going to go ahead and terminate. So like there's a number of appliances, like, and this is the other thing is like, if you go to your vendors and you think that you want to like have all of your vendors support termination, you may want to reconsider that strategy, because I don't know if you guys have dealt with certificate management. Probably fewer people have had to actually deal with that. But I mean, Chris Campbell, who's a great guy, gave a really fun talk about owning security appliances a few years ago. I think he was at Black Hat. But like you don't want to create your own like security, like the whole idea is like you have a less complex solution for security, so you're not creating new security problems with your security solutions and capabilities. So realistically, like we would advocate from like a design and architecture perspective, completely agnostic of what products you use, to look at like just establishing a monitoring layer and then terminating into that monitoring layer, because then all your old stuff works. Like it's kind of like, you know, free vacation. It's like, hey, like we used to know how to use all these tools and do all these things, and like if you do termination, for the most part, like you get all that back. So all the old stuff that worked now works again. The other big thing is like if you try to do termination on an appliance, the performance will tank pretty hard. So actually using like network gear to do things that network gear is really good at, we're big proponents of that, and we generally think that's a very good idea. The other option here is you can shift from a purely like content-based strategy to more of a metadata-based strategy. And we'll talk a little bit more about what that means. But realistically, it means that instead of depending on all of these different content analysis engines to do like real-time detection and some other pieces, like we essentially kind of move to a different architecture. So really quickly, I like pros and cons. This is part of the problem with like running a company and having people that you work with on a team, is like you start to just look at everything in the world with like, okay, what are the options and what are the pros and cons? So effectively for termination, like the pros are, like I said, everything just works. Like all my old stuff that like snort, you're back, you're here to stay, like I'm so happy about that. You have more or less full visibility of encrypted streams. Anybody that's tried to implement termination knows that this isn't exactly as much of a panacea as I'm painting it as, but it's pretty damn close. Like, let's just go ahead and say it is for now. The cons here are really around user privacy. So again, like if you guys are practitioners and you've talked about SSL termination or encryption termination in your environments, you've probably interacted with some people that are concerned about user privacy. What about banking? What about healthcare? Like, do our users have a right to privacy when they use encrypted websites? And I think that before, when most of the encryption was focused on those particular like web-based applications, that was a very powerful argument, right? Because like, hey, I'm a security guy, you know, naturally I want to have all of the data to be able to do all of the things. But at the same time, like, yeah, I mean, user privacy, like I'm a user on this network too. Like, yes, would I like privacy like when I'm doing my home banking? Probably. Should I be doing home banking at work? That's a whole other conversation. So effectively, like what you have to do here also is when you implement termination, you effectively add a certificate to the trusted root store on all of the endpoints. So like I was talking about like network versus host and all of these pieces. So you actually create another like fairly complex management piece, which is again why I would advocate for a single termination layer with a single certificate, and then you can like install that certificate where you need it. Because you're essentially, but when you do this, like, I don't know if you guys know how like SSL and TLS works. A lot of this is based around like the trusted roots that are installed either in your browser or on your endpoint. and your web browser like actually depends on this as like a source of authoritative trust. And so this is managed by like a small handful of companies, but like 2 of the largest are essentially like Google is a strong advocate and does a lot of really positive work around essentially like maintaining the integrity of that root of trust. And then also like companies like Microsoft and some of the other CAs that are very large also kind of participate there. But you're essentially breaking SSL and TLS when you do this. Like from a design perspective and root of trust, you're basically saying like, hey, I trust these big companies, and like there's a lot of, if you haven't looked at your like the certificates that are in this root of trust, you may want to do that. It's a whole nother like diverting, entertaining, like it's good for at least 5 minutes of entertainment. You won't need it this week, but like next week when you're like, I don't know, recovering, it might be worth checking out. But effectively, like you're saying that I'm better than all of these entities that are much larger than I am or dedicated to like maintaining integrity and trust like on the internet. Like I'm just going to go ahead and bypass all of that and put my certificate in here. And then the other piece of this is like you're going to have some issues around like if you have mandatory certificate pinning. So essentially like your certificate fingerprints aren't going to match up. And so the way that most browsers implement this is like it'll actually bypass, and if the cert's in your root of trust locally, everything will just work. So it's fairly transparent to the end user. For those of you that have interacted with or dealt with like IETF and like kind of the way that they're moving, like will that be that way forever? Will folks that are really passionate about privacy continue to let that be a thing, or will mandatory cert pinning be more of a end user configurable? Like how is that going to look in the future? Is it going to be a broken user experience? Like we don't really know, but we can kind of see the trend line, and that like it is definitely headed towards being a more broken user experience for end users. At the same time, like we really like content tools. So anyway, on the metadata analysis, pros and cons. So pros here, effectively with metadata, we don't have a lot of the same legacy issues that we got with content. With content, we all kind of became experts on storage and storage appliances. So like anybody that has maintained like a 30-day or 60-day PCAP store, sorry, can I do like a show of hands? Like, you know what I'm talking about? Like massive PCAP stores in or around your organizations. All right. Sorry, I'm like profiling the audience in real time, but I appreciate it. So like you're an expert on storage. With metadata, like all of a sudden like that same storage array that you had that was like super high performance for all the packets, like, well, you can now do a lot more as far as look back. You can start to look at not only like first order data, which is like the actual data in packets, but you can do things like data enrichment. There's a lot more, there's many more possibilities there. You can also like just the amount of look back that you can get for like metadata versus like actual full content is just, it's pretty astounding. The cons here are you're still in the storage game. Like, I don't know if you thought from the first part that I was going to say like, oh, storage is no longer a thing. It still is. You kind of need a lot more metadata to be useful. Like versus like, hey, I have a 30-second PCAP. Like 30-second PCAP, like as any network analyst worth their salt would say, is like I can do a lot with that. Like a lot of analysts use like a single packet and they can do a lot with that. A single metadata, like a single log, is not quite the same. 30 seconds of like metadata is really not quite the same. You're not going to get the same level of insight, understanding that you would from full content. The other thing here is like you're essentially becoming a like data processing pipeline business, like internally as a security team, because you have like things that generate data. You now need to make sure that like events from the thing that like the software agent that runs on the network sensor that collects the data go into like the aggregation and staging on the like appliance or the piece of hardware. And then you need to make sure that all of those events get written up to like a centralized data store. You need to make sure that those events get like deduplicated and cleaned and then moved to like some other like thing that you can query-ish. And if you want to do like more enrichment or get more out of that data, like you're essentially like, it's like Lego blocks, but they get like, there's a ton of more, like there's a lot more flexibility and options, but where like content, like you literally just write PCAP to like a file. And then when you need it, like if you're really like, playing your A game, it's time indexed. So you just like go grab the one PCAP file that you need, or you can slice it like using like T-Shark and you're just good. Like when you get into metadata, it's kind of this like, it's a very deep hole. And you can continue to go like deeper and deeper. So like, is network security doomed? I mean, no, we don't really think so. So one of the really interesting things about SSL and the way that like SSL and TLS work is that there's actually a whole lot of, there's a whole lot of new things that we get access to. And so this one, sorry, this is actually, this is DNS traffic. So like we start to look to other protocols to like augment our ability to see and understand encrypted traffic. I don't know if you guys can all read this. This is actually, so this is a DNS query for somebody once told me the world is going to roll me. I ain't the sharpest tool in the shed. She was looking at a dumb with a finger and a thumb in the shape of an L on her forehead. What is that? .md? .js.md, I think. So like this is the kind of stuff that actually happens when you start looking at metadata. Like the internet is a strange and wonderful and strange place. But there's definitely like techniques that can be really helpful here. So when we get to encrypted traffic, we essentially get a whole new set of metadata that we never had before the traffic was encrypted. So we get protocol version, so this is essentially like the version of SSL or TLS that's being used, cipher suites, server names, server subjects, server issuers, client subjects, client issuers, and validation dates. So essentially like when is their certificate valid for? And then we also have all the same metadata that we had before, right? So we have like IPs, we have flow, we understand how much data changed hands. If you guys take anything out of this talk, like hopefully like one of the first things you should take away is like, hey, termination may be like a thing that we should talk about, have like a framework to have that conversation internally. Second is like there is interesting metadata here around encryption. Like the number of times that like self-signed certificates are actually super valid for bypassing all of the content security measures on a network. It's kind of like astounding, and that's a sort like it stands out like a sore thumb here. Like if you wanted to go for bonus points, you could like actually validate each certificate that it's actually a real certificate, because not everything does that. But there's a lot here, and so essentially, one of the big questions here, we work a lot with like hypotheses and like do they actually work out in the real world or not. So one of the things here is like we can actually look at SSL metadata and infrastructure, because essentially like normally when you talk to threat intel people, they're like, oh, infrastructure is like these three things. It's like IP addresses and domains and who is, like this is what infrastructure means. This now kind of gives us another layer of infrastructure that we can actually look at and analyze. And so Mark Parsons, who's a super smart researcher who lives actually out on the East Coast. Justin's from the East Coast, I'm from the West Coast, so if there's like a common thing.
It's a good rivalry.
Yeah, sorry, it's a good rivalry. But Mark did a great talk at BSides Charm in 2016 by just pivoting on SSL infrastructure. So like what CAs, what certificates, what issuers, like he was able to effectively like increase his coverage up to over 100 times versus just using like domain who is information and trying to link that together. So like there's a ton more here that you can do, and this kind of goes back to like what does metadata mean, what data do you collect, how do you process it? Like by creating these huge aggregate data stores, like we can start to look at this, and even some of the vendors are actually starting to expose more SSL metadata and allow for you to do queries and kind of pivoting around in there. And so again, like walk away with something new to ask like whatever vendor you're talking to at Black Hat if you're going to go over there. I'm going to hand it over to Justin now.
Sweet. So when I came over from the red team side, one of the first things I want to do, like first week on the job, come in, shiny, ready to go, was break everything I did for 3 years as a red teamer using like our analytics platform. Essentially like how many analytics or detection techniques can I come up with, solely focused on how I was doing what I was doing, assuming that I was being somewhat threat representative and I was doing things like real world bad guys where and really what I ended up doing was forming some strategies around, essentially hunting through data to find abnormalities or interesting facts. Everyone defines hunting as something different, so I'm going to set somewhat of a level baseline, focusing strictly how we do it with the network data. So we look at proactive identification, meaning we're actively going out and performing something. We're not using like an alerting technique. We're not relying strictly on detections. It's a factor of it, but it's a slightly more manual human process. And we're focused on focused hypotheses, meaning we make an assertion about something and we go test that assertion. That allows us to be kind of scientific in nature rather than just getting a whole bunch of data and saying, show me evil, because like everyone in here probably knows it's not quite that easy, and it's not how it works. And so where we really focus in is like what's normal, where are the outliers, so like where are the protocol abnormalities, meaning things are not being used like they should be. How do bad guys leverage certain protocols? And then we take those different facets and actually go out and look for weird things in the data. So starting with what is normal, I think very few people kind of have a cross-baseline look at what is normal in terms of SSL TLS. And so for us we have a huge viewpoint working with our customers, we're able to kind of profile and I guess create a pseudo baseline just around the bulk of data around what we would see as normal in terms of statistics on specific feature sets. And so just looking at something as simple as TLS or SSL versions, you can see kind of the breakout of what's normal, and you can also see that still vulnerable versions of SSL are in prevalent use. And so just in terms of data set, this is across approximately, I think, 2 billion samples of 2 billion events over SSL. So good data set to look at these statistics. I think even more interesting is if you look at cipher suites and like what is common across cipher suites. Unlike where the TLS versions kind of settled on a modern, safe version, in cipher suites, there is tons of vulnerable cipher suites still being negotiated today on the internet. And so, and I would also add that there are differences between cipher suites being negotiated potentially in malware versus cipher suites being negotiated in normal servers. And that's something that is really good to dig in on and look. So we're going to dive through some analytics, looking at how we hunt through this data. We'll have some good talks. We'll poke fun at some real indicators, so yay. The first one we like to look at is kind of the commonality of particular SSL traffic, meaning our hypothesis is essentially around that bad guys, when they gain access to an environment using encrypted traffic, they're going to be on a relatively low number of isolated systems. Like, it's not entirely common, unless you're coming in with an incident response, that you walk in with every node compromised. And so generally it's going to be like a few number of systems, but those systems communicating to the certain servers are going to have really high request counts, meaning that there's going to be a lot of traffic from those low number of systems. So it should beg the question of, is this something that's popular or common? Why is it not on more systems? And if it's not popular or not common, why is it happening 24 hours a day, all the time on some sort of periodic pattern? And so when we look through this on our data, I think we kind of found or find that it's a useful feature to enrich upon, meaning that after your start investigation, this is a really good thing to tack on as a contextual enrichment to understand and better characterize particular flows. And it can be combined with other beaconing patterns. It's a really good way to kind of rule out advertising. And what I mean by that is if advertising kind of follows this characteristic somewhat, but in general, advertising you're going to see on a huge number of systems because there's common advertising CDNs and common advertising domains that we see everywhere. And we're going to show some examples of those later. And it breaks this analytic. So this is a good way to kind of weed out advertising, which, by the way, looks like some of the most malicious stuff on the internet. I would hypothesize that they essentially study attacker techniques to bypass anti-adware stuff or adware stuff. Yes, I hear a yes, yeah. So the next analytic we looked at was kind of send and receive ratios, essentially looking at byte count distributions and understanding is there predictable patterns with how malware over SSL will leverage the byte counts. And so what we saw is there's a extremely low variance in the byte count sets, meaning that when you look at large periods of time, in typical, bad guys are only working for a limited number of hours during the day, and not during those working hours, their malware's just doing some sort of characteristic beaconing, right? So if you're using asynchronous SSLC2, you are essentially going to have beacons rolling. If you're a bad red teamer, pen tester, attacker, you have them rolling like every second. If you are slightly more strategic, it might be every hour or 2 hours, or if you really like pain, every 8 to 12. And so in that case, when you look at a huge statistic set and break out the byte count distribution, there's going to be a whole bunch of requests that are the same exact size. Meaning that when you craft them over time and look at like a kernel density estimate, it's going to be like really focused on one of the particular buckets, which is not common across real SSL. The byte count will heavily fluctuate and vary. This is a potential good detection point for both data loss, meaning do I see huge uploads of data, as well as kind of profiling those byte count distributions. I would also add it's extremely tough to model in modern enterprises. Like, Americans and people around the world love to work all the time, especially hackers. And so they break this because, like, looking at, like, one good area to focus would be off hours. Like, let me look only at nights to look at these distributions, which is, might pare down our data. But people work all night and around the world, and they have VPN, and everything's accessible and open, and phones can be brought into networks. And so this analytic can complicate itself and get slightly more difficult. One of my favorite concepts, so as a red teamer coming into the blue side, one of the challenges I took on was how can I build an analytic that the attacker has no control over? Meaning, like, they have control over their beaconing times. They have control over their byte counts. They can make their malware fluctuate byte counts to break these analytics. One thing they have little control over is when they introduce themselves to an environment. Meaning, when you add something new to an established baseline, it should stand out. And so, looking at newly observed certs, essentially building a concept of passive SSL certs, like monitoring all SSL certs used in an enterprise, looking at first observation dates, and why something was newly introduced. Like if I have years worth of traffic collected from my environment, and I've never seen this SSL cert before, what is it? Because generally your business should be doing most of the same stuff year over year. And it can be particularly interesting. I like to think this is an extremely useful characteristic for like organic or internal threat intel programs, kind of extracting and looking at data from their enterprise to get a better understanding of the environment. And so what have we seen actors using? It's like realistically, we have all these fancy analytics, and like we're targeting all these bad guys doing really fancy things, but like when we actually look at real samples that we've seen in the environments and done response work with, 9 times out of 10, they were free or cheap certificates, like Let's Encrypt, Komodo, common providers that open this up. And generally DV cert specifically. We're going to mine you for intel. If you have seen an example that like completely counters everything I just said, like you've seen attackers using EV certs, like send it to us because we're really interested, and we'd make the hypothesis that's probably pretty uncommon, not something that we've seen a ton of. So this naturally brings us to our favorite topic, which is Let's Encrypt. Let's Encrypt is an awesome program that's really trying to promote privacy and bring SSL everywhere and TLS everywhere. The interesting part is when they brought out SSL TLS, there was a lot of feedback or criticism from certain parts of the security community around why are you enabling encryption to be so easy without any validation or integrity around who purchased the cert. And so Let's Encrypt put out a blog that was essentially stating they believe that it's not the provider's job, it's not the issuer's job to control or verify people over SSL. And so what does this really mean, or what is the big deal? I think we have to start with what is the difference between DV and EV certs, because that's really what they're getting at, is they don't believe that it's their job to validate identities of people. They believe it's their job to validate the identity of a certain technical owner of something. And so in DV certs, and by the way, I'll be the first one to admit I didn't know how to recognize this until like a couple of weeks ago. And so as a security practitioner for years, like I couldn't look at a browser and tell you difference between DV and EV. At the bottom, you can see the difference. DV says secure, EV says the actual corporation name that's been validated. So DV meaning all you validated is that someone owns a domain. My build script for red teaming included an automatic cert bot that like went and pulled my Let's Encrypt cert from my domain I purchased. Meaning I can in seconds get SSL TLS encryption on my C2. Like no effort, no validation, no email, no info provided. All I did was prove that I own a domain. Like very simple. And domains cost, 80 cents. So it's really not too hard to get in this world. EV certs being that they've actually validated the enterprise. Not impossible to get around, I'm sure. There's really fancy organizations. Typically much more work and a lot higher cost, which is going to be a turnoff for most attackers. So awesome. Who uses DV certs? So when you look at statistics across our database, looking at the different issuers that we see, I'd like to just point out that these are like the most common issuers across multiple billions of samples. So these percentages are pretty high, like high request counts. You'll notice that like DV certs are in prevalence here. So Komodo being one, some of the DigiCerts and Intrust and GeoTrust, like they're all there. Let's Encrypt is actually pretty high on the list. It kind of a little bit below here. I think it's around 1%. But huge players, huge prevalence in the community. DV is not going anywhere. It's only growing in popularity in terms of the internet. Which really brings us to the conclusion of we have to change our mindset. So there was a really good exchange on Troy Hunt's blog pretty recently, a couple days ago, like very timely. I saw it. I'm like, yay, a new slide. I can add it in. A really good exchange around the perceived value. And so I think when we get into this argument and growing popularity of DV certs, for us, we really think that the internet has to help our users change our mindsets around SSL and TLS does not mean legitimate. So like for the early years in the 90s and late 2000s, it was so expensive to get an SSL TLS, and it was something that required so much work that they were like, you would see encrypted traffic and you're like, oh, that's that's okay. It's encrypted. Like they did work to get a cert. Nowadays, that's not the case. And so we have to start educating people that SSL simply means it's private, not safe. And really pushing us towards going and, yeah, yay. I like claps. It's a first for me. And so I think for us, this is really pushing towards the hypothesis of let's go look here more and let's get used to working with encrypted traffic. So if you weren't believing me this whole time, we'll go show some stats and call out some domains. This is fun. So who would actually abuse free certificates? Like, oh my God, who would do this? Well, I'd say the biggest consumers of Let's Encrypt in our environments that we see are actually advertisers. Like I said, advertisers are kind of evil. And so I don't know if you've ever looked for these domains. I would challenge you to go look for like lytics.io. It's everywhere. And it's basically a, add CDN kind of capability that uses Let's Encrypt. So like highest percentage and like huge prevalence in our data sets. Also some of Swoop and RLime and all the other common sites you might see using this. There are big providers moving to Let's Encrypt. It's becoming more popular. We would also say that due to Let's Encrypt being really easy and due to me being as a red teamer who used it all the time, I would argue that bad guys are probably using Let's Encrypt more prevalent than other providers. It's just, again, a hypothesis of mine. And so when we went looking through the results based on that hypothesis and started hunting through some of that data, here's just a snapshot of what we found. So a lot of XYZ domains, which like should be an analytic on its own. Like if anything's .xyz, it's evil. Same thing with .top to some degree. So if you have a .top domain, I'm sorry, because I kind of just insulted you. But we found a lot of park name cheats and phishing domains and Ukrainian WordPress sites and all sorts of just really sketchy things were really prevalent in Let's Encrypt. Things that we probably wouldn't want flowing over our average corporate network and being used by workers in our enterprise. So jumping into phishing, really looking at Let's Encrypt phishing. So like I said, as a red teamer, we literally use Let's Encrypt for all our phishing stuff and pretty much all our C2. And so when we dive in on this, let's look at some samples. So you'll see this is a good phishing link that was sent out to providers, also using Let's Encrypt. Nice little lure, nice little credential stealer.
Eric Lawrence is not the person that you want to send phishing emails to, basically. Yeah. Eric Law is like used to be a lead developer on IE and now is a lead Chrome developer. So sending him malware, I mean, you can send him malware samples. I'll just put them on Twitter. But yeah. There's
a couple really good Twitter accounts to follow for stuff like this. That's one of them.
Yeah.
John Lambert's another really good one. And so, I mean, essentially what we can show here is that phishing is becoming all the rage using Let's Encrypt and malvertisers and bad guys. Like we've been saying this over and over. It's a good place to go hunting. It's not all evil, but it's certainly interesting.
So this is where we get into the forensics part of the talk. I've given this is a much updated version of this talk, but the last time I gave it, I really focused a lot on hunting and detections and really showing like, hey, detections are not over just because we don't have content. But some of the feedback I got was like, well, we actually want to talk about forensics. Like that was in the title of the talk. Why didn't we talk more about it? So we're going to talk about forensics. Forensics can sometimes be fairly dry, so I'm going to try and treat this at a high level. We'll try to make the slides available if you guys want to go into more detail and like dig in deeper. But essentially, this is the detection of forensics, like kind of like overall like how we move through the process. So initially, and a lot of what we've been talking about is like the initial identification of suspicious traffic. We're going to move on from there to effectively analyzing content for artifacts. So like traditional network forensics, or traditional even like host forensics, you're going to pretty much go the same place. Like you start with something that you want to look at, you then go like, okay, what content is relevant to this investigation? You're then going to analyze that content, those artifacts. That could be anything from like binaries to domain names or any of those pieces. After that, you're going to essentially like all roads lead to Rome. You're building a timeline. I mean, all the forensic investigators probably in the room have had the experience of like time servers not being in sync and like trying to go from like an Excel sheet to a PowerPoint presentation for an executive. Like these are the joys of being a forensic investigator. And then ultimately impact analysis and presentation. Like I hate to say it, but if you're doing forensics and you're in an organization that really cares about it, I've almost always had to do a PowerPoint presentation. It's not my favorite, but typically you're making it in some kind of like view that somebody who is maybe not as familiar with like the content or the artifact analysis, like, okay, what happened? And like, was it bad? Like that's ultimately where we're all going to. And so there's a whole lot of different pieces that I'm going to go, like that you can, like we'll put this online somewhere.
Sure, probably.
So effectively, like, let's look at the process before we have network encryption, right? Content's a thing. Let's just say like we have malicious traffic over unencrypted HTTP. This is pretty much like probably the most generic example for this kind of environment. So effectively, since we can see the content, we just get to go like, okay, something's bad. Like we had some kind of detection event that led us here. Now when you do forensics, we basically can look at all kinds of things. We have the IPs, we have the host headers, which is HTTP protocol level data. So it's going to be part of that content. We also have the payload and content. So we have full content, URIs, parameters, response codes, user agents, cookie values, request response bodies. Like if there's an actual file transferred in HTTP, we probably also have that. And so the overall analysis in network forensics on like bad traffic over HTTP, fairly straightforward. Like if you look at that kind of flow chart, like you have all the pieces, it all kind of flows in nicely. For this is a PE download from Chupa. If you guys know like Chupa and Vultr, I'm guessing both the red team people are familiar with it, and probably some of the blue team people in the room are also familiar with Vultr and Chupa. These are ASs that are generally very easy to set up VPSs on for red teams and other people. Like it's not just red teams, like there's actually legitimately bad shit in Vultr and Chupa. It's an interesting part of the internet.
Remember I said .xyz, this is real, rat server, totally cool name.
Yeah, so this is actual real traffic, sorry. Like in a lot of these examples, like we'll try to call out whether or not we made it up and like did it for this, which like the demo that we're gonna do at the end, we totally did make up because live demos are terrifying. But this is like legitimately, like it's just a PE download and we can see like the timeline's already there. Like we have the PE download, then we see the traffic out, and then we can see the net flow associated with that. So like what happened, like okay, it downloaded malware, and then we saw it beacon out to this IP address, like timeline, like we probably are gonna still go to host analysis to finalize impact. But like overall, like this is a very straightforward process. So we have content, we analyze the infrastructure, we do the timelining, and then we like, that's my like PowerPoint graphic that somebody made for me. But yeah, that's a PowerPoint graphic in a PowerPoint presentation. It's a high point for me. So network forensics after encryption. So this is a little bit different, right? Because our detection mechanisms, like if I'm in an environment that hasn't really updated network security since like let's say the early 2000s or like the mid 2000s, like you're kind of screwed. Like all your content detection stuff is basically like sitting there generating heat in a rack, but it's not actually generating a lot of detections for you. One of the really easy ways to look at that is actually if you look at the types of detections you have and like do like group bys on like what signatures are firing and start to look at that over time, you'll start to see like fewer and fewer of certain types of signatures. So like sorry, I'm not gonna go all the way down that rabbit hole. But essentially here, like you basically live in a world where you can like do things like match IPs. So like if you have no termination, you're not really collecting any SSL content metadata, you're basically like, okay, this IP address is bad. And anybody that's done investigations or detections or like actually tried to operationalize threat intelligence knows that IP-based matching is not the highest fidelity source of truth when it comes to that. And then we also don't have any HTTP protocol metadata. So remember all the things that like showed us which file got downloaded. We had file metadata. We saw like a post request out to like a malicious C2 server. We had the host header, so we actually knew what website it was going to. We don't have any of that. So one of the issues here is like, think about, I don't know, malicious actors that may or may not host infrastructure on AWS. AWS EC2 IPs are fairly reused. We have things like shared hosting now. If I only have the IP address, like my job becomes very difficult. I don't have like a clean timeline, and like, how do we disambiguate between like legitimate usage of EC2 endpoints and like illegitimate usage? Like this starts to become fairly challenging. On the left-hand side, I love that we have this in here. So like, here's some like, these are actually Intel matches. So for SSL, we can see these are IP addresses, it's encrypted traffic. Then we're then pulling in essentially the threat intelligence metadata. I think this came off of, John Bambenek's high confidence C2 IPs feed, which is freely available through like MISP and a whole bunch of other places. But that's pretty much all we have. We have like a NetFlow record, we have an SSL record, and that's pretty much it. So like filling in the timeline becomes a little bit more difficult. So we effectively have to build out new, like a lot of this talk is about like looking at new data sources and building new techniques. So effectively, like we can't just match HTTP host data anymore to disambiguate like which website was being accessed on an IP address. So we can start to do like get more out of the SSL certificate data. So we can look at server name and subject field. So where we used to use HTTP host headers. And then since we don't have the HTTP payload data, we can actually start with an IP address and an event time. And then if we have things like time index passive DNS, we can actually pull like this concept of like tight time-bounded passive DNS. So if I'm watching every client in my environment and every DNS request and response, I can actually tell you what host was requested, because like if Justin requests it, I can just look at the time period immediately preceding the SSL like connection stand-up and like what did he actually make a DNS request for, and I can now start to like disambiguate. And so like their powers combined, essentially like server name and subject field data, as well as tight time-bounded passive DNS can be really useful. And then for like interpreting the content, so like was it a binary download? Was somebody uploading data? Like where does it fit in a timeline or like potential TTP? That's really where like data sent receive ratios can come in really handy. Like Justin talked about how they can be problematic for detection, but for forensics, they can actually be really useful. Like HTTP traffic by far uses like fairly similar data ratios. You can actually fingerprint different types. There's some really good papers out on like PCR. It's called a producer-consumer ratio in most of the papers that are out there, but it's a really useful data point to have, especially when you're trying to reconstruct things without actually having the things you're trying to reconstruct. It's like a black box approach to network forensics. So effectively, we start with a starting point. We start with essentially matching on domains. So instead of matching on domains in HTTP data, we can match on those either in DNS, which is highly problematic, or we can do it in SSL, which is a lot less problematic. And then we can effectively continue to analyze infrastructure and IPs. We can use that tight time-bounded passive DNS to confirm, like, okay, was this actually the host that was accessed? For timelining, we essentially are going to pull all of the events, so all of the flow data, all of the certificate metadata, and effectively look to see, like, if is it hosted on like a single IP? Is it in, essentially a cloud or shared hosting environment? And then we can pull the data sent received ratios across different time buckets to try and ascertain what type of activity was actually going on that this host was doing. And then we can put it in PowerPoint, which is pretty much the same. Like it all still ends up in PowerPoint. Sorry. So to kind of wrap things up, and please feel free to ask questions on this. I think we still have a little bit of time here. We tried to leave some there. So encryption isn't the end of the world. It sounds like a lot of vendor speak, and a lot of different vendors will try to influence you in different ways. We're pretty firm believers from just like a research and like completely product agnostic position. Like you can collect this data. There are many products you can use to collect this data. You should collect this data, and it will be useful to you. You essentially have like, recap, you have two options. You can terminate. So like if you have a very old legacy environment and you don't want to have to learn a whole bunch of new tools, termination is probably your friend, but you're going to have to fight that user privacy battle. Otherwise, you have the option to shift more towards metadata, which really is looking at leveraging features of encryption for analytics, intelligence, and essentially that detection and forensics piece. And I mean, honestly, there is a huge way forward for this. Like we're very early as a research community. I mean, I called out Mark Parsons because I think he's awesome, and he does some really good research around this. But detection by looking at predictable or notable features around SSL certificates, and like Justin was saying, like we were really disappointed when we started looking for this, and we mostly just found like malware using self-signed certificates. Like that was kind of a bummer for us because we were like, oh, check out this awesome like analytics. It was like, no, we're going to start with blocking and tackling, like many security pursuits. Like let's start at 0 and then work our way up. So there's a lot of value here. And then overall, like forensics isn't a dead science just because the data is encrypted. Please don't let it become a dead science because the data is encrypted. It's lower fidelity, but we really still feel like you can build a lot of the critical information, still build a timeline, and ultimately still be able to present a PowerPoint up to your security leadership. So I had a friend dare me to put a security maturity model in for this. This is, again, like twisted things that make sense when you're like doing, company running stuff. You're like, oh, we should have a maturity model. And I was like, touche. You
should troll them for this acronym because it's silly.
Yeah, you can see that I maybe had a little bit of fun with the acronym here. This is essentially I really do, like in all jokes aside, like maturity models can be really useful. This is really meant to be like a measuring stick for like, hey, I'm an organization, like how am I doing on this? Like that guy talked a lot about like encryption and security, and so there's something about detection, and then some hunting stuff, and then some forensic stuff. Like where am I on the chart? So effectively, we start out with content because everybody already has this. So like, do you have content termination in place? And it's people process tech. So like, if you have no people allocated to this, you don't have a capability. So like, it starts out with having someone like analysts or what actually make all of this work. Like without analysts and process, like you can buy all the shiny kit and the vendor hall that you want, but you're not going to get anywhere. And so like you have someone assigned to this, you're actually terminating traffic, and then your technology, like you can actually do this at a web gateway or a web proxy. So like a lot of appliances are starting to do this, and you can buy those. You just want to make sure it's actually turned on. Like if I had $1 for every client environment that we'd walked into where they're like, oh yeah, we're terminating all the SSL, don't worry about it. It's like, go actually validate, like this is what this one person can do, and they may or may not like you afterwards, if you're their coworker or boss, but like make sure it's actually turned on and working in all these different places. Like that's essentially like starting out here. Level 2 is really looking at kind of like how much more can we do with content. This is where you get to that like termination layer. So effectively you have a monitoring layer where you have like a packet broker. So that could be a commercial, like that could be like a Gigamon where like they make it super easy. It's plug and play. That could be an Arista because you have legitimate amounts of traffic and you don't need all the UI stuff. But you essentially, for tech, you have an SSL terminator and you have a TAP architecture or data broker that's like connected to that. So like at that point, you're doing like 2 thumbs up on content. You're ready to rock and roll. Metadata level 1 is really about having comprehensive visibility and logging of DNS to a central repository, and then making that DNS data accessible to analysts. So like, can an analyst actually query that DNS data? Because I've met a lot of people in the network security realm, they're like, we have all the packets, or we have all the DNS. I'm like, okay, great. Like, can people get to that? And then those people who are usually like the architects or engineers kind of look at me like, what do you mean? I'm like, analysts, like they're the ones that actually do the job for the business. So like both having it and making it accessible are key points here. As far as technology, you can really just do this with DNS metadata extraction and logging. There's a couple of open source projects that are pretty good for this. If you just want to set up basic DNS logging, I would strongly recommend that you do it at the network layer and not try to do it at the host layer. So like most environments, like all the DNS is aggregated essentially on Active Directory domain controllers, because this is how everyone set up their domains. This is how everyone set up DNS. It's a recommended configuration from Microsoft. Don't try to install a bunch of logging facilities on domain controllers. Like for legacy versions, you actually have to put it like basically in a debug state, and then you're writing a whole bunch of DNS logs to disk. Hint, there are a lot of DNS logs. If you've never looked at DNS and like the flow rates and all that, I'd be lying if I said we hadn't tried to help a customer do this and then blue screened one of their domain controllers, which they were not happy about. So like, please do it at the network layer. You will be happier, I promise. So layer 2 here is automatically linking DNS and IP resolutions based on time period, basic data, and data flow calculations. So this is kind of that like tight time-bounded DNS that I was talking about. To really do this, to do it in real time, we're talking about big data stuff, and I'm going to qualify that because like I know this vendor got up and talked about big data, and like nobody threw anything at me, which I appreciate. But like realistically, like you're talking about multiple, probably in a decent-sized enterprise, like terabytes of data a day that need to be written in, and if you actually want to be able to query this in real time, you're talking about like a streaming real-time processor. So you're probably talking about like something like Spark-ish and Hadoop-ish, like HBase-ish, Cassandra-ish, and basically having all that architecture up and running, and then having web services on top of that. So like I didn't just say big data. Please, Justin will troll me about it later, but it'll be fine. And then level 3 here is really about data flow analytics, getting more into like, okay, you have all the data, it's accessible, but now we're actually going to do a lot of these like big data crunchy analytics on it. And essentially this is about having an analytics layer that lives on top of all the data, all the other things that we were just talking about that like make the data like collected and accessible. And then you're really like, you know, as far as we're concerned, you're cooking with fire and you're at the top of your game. And if you can get to both like the highest level of maturity on both content and encrypted data, we feel like everybody will be in really good shape, and we'll all feel like we did a good job on this talk, and you know, everybody did awesome. So one of the big things that we really enjoy are questions, and we've talked about a lot. So please feel free to ask us questions. We're also happy to answer questions after the talk. We'll be hanging out for a while. Yeah, up here in the front, and I know the guy with the mic is probably going to hunt you down.
So you mentioned that you saw differences in the SSL certs between normal traffic and the malware. Could you elaborate on that a little bit?
Yeah, I mean, so like in the most basic sense, like, so there's two things that happen. One is that like malware uses self-signed certificates. Not a lot of other people do, because in a browser, like the browser will be like, oh my God, it's a self-signed certificate. Like Firefox has been training us as users of like, I mean, like my parents know not to like browse to that website, whereas like backdoor clients don't have to validate certificates. Like that's a client-side thing that happens. Like some people get confused of like what happens on the client, what happens on the network. So like you actually will see people using self-signed certificates, like, and they will almost never do that in a legitimate browsing session because of the my parents principle of like, oh my gosh, like Will, I like saw this thing and it was like it's not signed, and yeah, like my parents have actually done that before. Kaspersky install was awesome. Sorry, did that answer your question?
Yeah.
Okay.
So I was curious if you had any thoughts on the TLS 1.3 debate for the big enterprise and the fact that they're complaining right now about the TLS 1.3 specification because they can no longer do man-in-the-middle attacks inside their network.
So, I mean, basically with TLS 1.3, I don't know if you guys, so one of the big rants that I did at Microsoft is I like ranted and raved and worked with the ITF to like remove RC4 as one of the ciphers moving forward, because it's terrible. You should never use it. If you ever see it like negotiated on your network, you should be concerned. It's not actually encryption. It's kind of like a zipper, and if you just pull on the right side of the zipper, like everything just becomes unencrypted. Like stream ciphers are bad. We could talk about that later. But I think with TLS 1.3, I think that the way it's all going to end up in the end, like it's all going to come out in the wash, is that trusted root is still going to be the source of truth for every endpoint. And I think that it's so, like, having worked at Microsoft, like the user story of like, hey, all these things are just going to break, and everywhere where you have like PANs, like your Palo Alto networks, gateways deployed and doing like SSL termination, like that's going to be a broken experience. I think that the IETF can do a lot of things, but I think at the end of the day, usability is probably going to win out. But kind of like I was alluding to, like with that, like, hey, is this a long-term solution? I think eventually user privacy has enough behind it that, we're going to move into a world where everything really is about, a web services architecture. It's all service-oriented, and like at that point, like I think clients are going to become less and less of a thing. It's going to be more about like I have a user agent. But I think it'll still be up to both the user agent people. So effectively, that's more and more becoming Google and the Chrome development team. And they seem to be pretty privacy leaning. And then also the OS manufacturers that really are the ones that implement like root of trust. Although technically speaking, some of the user agents, so the browsers implement their own root of trust, and that's a whole nother. I'm trying not to make this talk just about like me ranting about TLS. But it's a very interesting, like, yeah, after you check your trusted root contents and you're bored next week and like recovering, you could also like look at how TLS works. It's a lot more convoluted, and after you see the people whose names are on the trusted store, you'll probably be pretty curious about like how that, like Gator certificates or something like that.
There was also a funny tweet that I went out really recently where someone went and cleared their entire, I think it was Casey Smith, Sub-T, I think he did it, where he cleared his entire trusted store and then just like rebooted his computer to see like what repopulated. And basically, they all just like came back poof. Like, so like managing your own trusted store is not like as simple as it can be either.
Yeah. Nobody wants to break users, right? Like, no one wants that. But at the same time, like, there's all these other competing pieces. So, long story short, like, our opinion is it's a changing environment. I don't think that it's going to be this round that like privacy rules the day because it's going to be so broken of a user experience. But will that continue? Like, I don't honestly think so. I think we're going to get to a place where we really do have to deal with analytics on top of encryption instead of relying on interception. Back there in the...
Yeah, just a quick comment for Justin. You were a little critical of advertisers and using free and cheap certs, and I just wanted to comment that I'm actually applauding advertisers for finally encrypting traffic. How long did we see mixed mode, them including random JavaScript that I could easily malvertise my way into a domain? So I think part of that was, the browsers kind of forced their hand because mixed mode became much more apparent to the user. But I really applaud advertisers for finally taking up SSL.
Awesome. Thanks for the comment.
We appreciate and value your opinion. As former red teamers, like, yes, we've intercepted mixed mode content, At the same time, it's one of those things where like, since advertising basically creates like a new fresh hell for us on the like analytics front every day, I think we can sometimes be a little harsh on them. I'll give that.
I'm guilty of that.
Yeah, generally speaking, like advertising is, you know, I don't know, like I live in a world where there's like good guys and bad guys. I'm not going to put them in either camp, but you know, sorry if we offended the advertisers. Please do continue to encrypt traffic. Otherwise, red teamers will likely continue to intercept your traffic and do bad things to users. So, all right, I think there was one other question, or another question over here.
Yeah, this is more of a comment. Another thing that you can add to your SSL termination con list.
Yep.
A lot of API providers are now requiring client authentication. So it requires mutual authentication. A lot of it's certificate pinned. This is breaking, I know in my own environment, this is breaking our ability to do SSL termination and to inspect the traffic. So
absolutely. I mean, that's a super, yes, we will absolutely add it. It is a super valid point. It is becoming more and more common. Most people don't even know that you can do that. So I applaud, like to be really honest, like most people don't even understand that like there is a client server. They either assume that it always has client server authentication, and they don't understand that the root of trust is really like external to them, or they don't understand how the client server authentication works. It's kind of a pain to do, but yeah, I absolutely would agree that, you know, there's more of it going on. And, you know, it's definitely going to also cause issues because no matter what if you have client authentication, the man in the middle stuff is not going to work. Like that's just basically going to break. And that's actually why there was an asterisk on that slide where it was like, it's a panacea. It's not actually a panacea. Sorry. Like not everything will actually route over your termination gateway, and like people use client certs and all just work because nobody wants to break users. So was there another question or comment over on that side of the room? Oh, we got one over there.
Yeah, hi. It's a great talk. There's another paper actually at BSidesDC last year on doing SSL cert analysis and looking at the fields, not just for self-signed certs, but also the regular signed certs. And there's some very interesting attributes in there. And then if you apply a machine learning model on that, you can actually extract out which are malicious and not. So you can go look it up in that at BSidesDC.
Yeah, I mean, you can absolutely do more complicated analytics on top of it. I would say like our original hypothesis is that like, oh, we're going to have to do that. Generally speaking, so sorry, totally hear you. There's a lot of interesting things happening around like analysis of any metadata and trying to use machine learning to find outliers or build models that we can train to like recognize like malicious or not malicious traffic. I would advocate strongly like in the maturity model, like I'm just like collect the data so you have it, and then you can like have like really smart machine learning people that you find that can help you do things with it. I mean, most people just don't have the data to begin with. And if you don't have like DNS data, which most enterprises we interact with don't have, like global DNS data, and like, so I mean, how are they gonna get certificate metadata? Do they even look at it? Like which contents they actually look at? Like there's actually more metadata that you can get outside of like, we haven't even talked about like SSL, like different SSL handshake properties. The protocol is inherently super complex. So like there's tons of places where you can go deeper and deeper on this. But please just collect the data, because if you don't start collecting the data, there is a time when content interception is not gonna be as much of a thing anymore. And if you don't have the data that you need to do network forensics, you'll probably be on the end of the world wagon. And we want more people on our wagon where it's not the end of the world. So yeah, I think it's a super valid comment. Thanks.
Apologies, but that's all the time that we have for questions today. If you'd like to continue the conversation, make sure to follow the authors on PeerList. And please give a round of applause to our speakers.
Thank you.